All right, in this video, we're looking at geometric sequences. This is a geometric sequence right here. 3, 12, 48, 192. You can see that it has a common multiplier. We're multiplying by 4 each time. That makes it geometric when you have a multiplier. Okay. The formula for this is a sub n equals a sub 1 times your common multiplier to the n minus 1 power. All right, so this one here just wants to find the common ratio r. And this is multiplying by 4, so this is just r equals 4. That's all we're doing here. So that's the same thing here. What's the common ratio here? All right, 5, negative 50. This is multiplying by negative 3. What you can tell is just take this number here, divide by that number there. Okay, it's really important to do that. This number divide by that one, because when you get to something like this with fractions, it's very important. Do 16 thirds divide by 8 thirds. Okay, and just punch this in the calculator, and then when on this one, you'll get 2. So r is 2. Okay. Some of these may be hard to figure out unless you do the division. So, like on this one here, just take this second one here, and we'll divide by the first one. All right, so 76.8 divided by 64, and it looks like 1.2. So your common ratio is 1.2. All right, this says find the nth term of this sequence. So n is 6, r is 3. So in my equation, a sub n equals a sub 1, which is 5, times my r, which is 3, to the n minus 1 power, which in this case n is 6. So it's 6 minus 1. And so I just punched this in. So 5 times 3 to the 6 minus 1 power. Looks like 1215. Okay. Number 6, find the nth term here. All right, remember now, a sub n equals a sub 1 times r to the n minus 1 power. All right, so we want to find what the nth term here is, which is 8. So we want to find a sub 8, which is a sub 1, which is 3, times my r, which is negative 4, to the 8 minus 1 power. And when you have a negative like that, you need to put in parentheses. So 3 times negative 4 in parentheses to the 8 minus 1 power. And it looks like negative 49,152. That'd be my answer. Okay. Find the nth term here. We want to find the 5th term. See, n is 5, so we want to find the 5th term. All right, so a sub 5 is going to be a sub 1, 2560, times my r, which is 1/2, to the 5 minus 1 power. Okay, so 2560 times, in parentheses now, 1/2 to the 5 minus 1 power. And it looks like 160. Okay. Number 8. Find the nth term here. N is 6, so we want to find the 6th term. So a sub 6 is going to be a sub 1, which is 1/3, times my r, which is 1/4, to the 6 minus 1 power. Okay, again, a sub n equals a sub 1 times r to the n minus 1 power. So there's my a sub 1, there's my r, and then n is 6. So I just punch this in. And this probably needs to be in parentheses. So do 1 divided by 3 times 1 divided by 4 in parentheses to the 6 minus 1 power, and that looks like, okay. Negative 4 means this moves back 4 places, so 1, 2, 3, 3, 2, 5, 5. So this is what my answer would be, something like that. And I think it wants it rounded to the nearest hundredth. So this would be, if now rounded to the nearest hundred, be 0. I don't think you'll have one that goes this big of a decimal, or this small of a decimal rather. Find the nth term. N is 8, so find the 8th term. So again, a sub n equals a sub 1 times r to the n minus 1 power. All right, so a sub 8 is what we're looking for. We're looking for the 8th term. A sub 1 is 2 times my r. This looks like 2 times 4 is 8 times, looks like r is 4. And then 8 minus 1 power. So there you go. 2, 4 to the 8 minus 1 power. And that's 32,768. All right. Find the nth term here. N is 12, so I'm going to find the 12th term. All right, again, a sub n equals a sub 1 times r to the n minus 1 power. All right, so a sub 12 equals a sub 1 is 5 times my r. Now this looks like it's multiplying by -2, so there's my r. And then we'll put 12 minus 1 power. All right, so punching this in. Okay, clear it off there. I have 5, and then I'm going to have -2 in parentheses to the 12 minus 1 power, and that is negative 10,240. Okay. What about this one here? All right, find the nth term here. So a sub n equals a sub 1 times r to the n minus 1 power. All right, there's my a sub 1 right there. So a sub n equals 1/2 times my r. Okay, so I'm going to have to take 1/6 divided by 1/2 to figure out the r. So 1 divided by 6. So 1/6 divided by, and then this is going to be in parentheses. Oops. Okay, I'm probably gonna put the first one in parentheses too. I might have a mistake if I don't. There you go. So 1/6 divided by 1/2. And that is 1/3. And this is going to be the n minus 1 power. And there you go, there's a sub n right there. Okay. Find a general term a sub n. That equals a sub 1 times r to the n minus 1 power. All right, here's a sub 1 is 5, r is 2, so a sub n is going to be 5 times 2 to the n minus 1 power. And there you go, there's a sub n. Okay, find a general term a sub n, so we're just doing a sub n equals a sub 1. A sub n equals a sub 1 times r to the n minus 1. I was doing an arithmetic sequence. This is geometric. All right, so a sub 1 is 1/5. Okay, times my r is 3. And there you go. You just put them in right there. And here's another one. So a sub n equals a sub 1 times r to the n minus 1 power. So my a sub 1 is 4. My r is 1/5, so I'm going to put it in parentheses. And there you have it. Okay. Number 15, find the general term again. So a sub n equals a sub 1 times r to the n minus 1 power. So there's a sub 1 right there, that's 1/5. Times my r, which is 3 to the n minus 1 power. And there you go. A sub n equals a sub 1 times r to the n minus 1 power. All right, so there's my a sub 1 right there, 1/5. Times my r. All right, my r, I gotta take this one, divide by this one, do 3/5 divide by 1/5. Okay. Now I think it's just gonna be 3. And there you have it. You punch in the calculator to make sure, but I'm thinking it's just 3. So 3/5 in parentheses divide by, in parentheses, 1/5. Yep, 3. So I was right. Okay, 17. Find the first term and the common ratio for the geometric sequence. Round approximations to the nearest hundredth. All right, this says that a sub 2 is 4. A sub 4 is 64. So let's do this. There's a sub 2, a sub 3, a sub 4. This number is 4. This number is 64. All right, so now we're multiplying and we're multiplying again, which means I'm squaring something because I got something I'm multiplying twice. So if I just do 64 divided by 4, I get 16. And now take the square root of that answer is 4. So that should be my r right there. R should be 4. 4 times 4 is 16. 16 times 4 is 64. Yeah, that's right. Okay, so since there's 1 between these, this is going up 2 times. See, this is multiplying and multiplying again. It's multiplying twice. So there you go, r is 4. So it says find the first term and the common ratio. All right, so here you go. A sub 2 equals a sub 1 times this ratio to the 2 minus 1 power. Since a sub 2 is 4, all right, so a sub 2, which this should be 4 here and right in there, equals a sub 1 times 4 to the 2 minus 1 power. All right, so that means 2 minus 1 is 1. 4 to the 1 power is just 4. And I divide both sides by 4, and there you go. A sub 1 is 1. So there's my ratio, and there's my first term. Okay, number 18. Find the first term and the common ratio for the geometric sequence round approximations to the nearest hundredth. So here's a sub 2 and a sub 4. So again, we got a sub 2, a sub 3 we don't know. A sub 4 is 9. So there's what we have. All right, so if I take this one, divide by that one, 9 divide by 36. Okay, I get 1/4. Okay, now do the square root of that. Since this multiplies twice here, I do the square root of 1/4. So I do the square root of that answer, and I get 1/2. So there's my r. So 36 times 1/2 is 18. 18 times 1/2 is 9. So yes, this is correct. Okay, so there's my common ratio. Now what's my first term? All right, so to do that, I'm going to take the second term here. All right, so a sub 2 is 36. That should equal a sub 1, which we don't know, times my r, which we found out r is 1/2. All right, to the n minus 1 power, which n is 2 in this problem, so 2 minus 1 power. Okay, now 1/2 to the 2 minus 1 power is 1/2. And so I divide both sides by 1/2. So 36 divided by 1/2 is 72. Okay. Now we have 2 word problems, and that's it. So number 19. A woman borrowed $40,000 at 15% interest compounded annually. If the loan was paid off in one lump sum at the end of 8 years, how much did she pay? Okay, so now here's the thing on this. When you do a sub n equals a sub 1 times r to the n minus 1 power. Okay, this has $40,000, so there's my ace of 1. Okay, now my R here, well, my interest rate's 15%, so that's 0.15. That's my interest rate. But now when I multiply this, when I put this in, I got to put 1.15 to the n minus 1 power, which is 8 years. So I got to put 8 minus 1. And now I can put, so here's the thing, what I'm trying to say is this is your interest. So this is what it increases. It increases this much, so it's 1 plus that, which is 1.15. So 40,000 times 1.15 to the 8 minus 1 power, and there you go. 106,400.7952 and 106,400.80 is what that would round to. So there's how much she paid at the end of 8 years. Okay. And then number 20. The town has a population of 5,000 people and is increasing by 8% every year. What will be the population at the end of 12 years? All right, so a sub n equals a sub 1 times r to the n minus 1 power. All right, so what's the population going to be in 12 years? A sub 12. All right, well, it's going to be my a sub 1, which is 5,000, times my rate. Well, see, this is going up 8%, which is 0.08, but I got to add 1 to it, so it's 1.08 to the n minus 1 power, which is 12 minus 1. And so I just type this in. Okay, so I got 11,658.19499. Okay, which is 11,658.19. That's how much she paid at the end of this. Okay, there you go. That's geometric sequences. If you need some help with this, let me know. I'll help you all I can. Have a good rest of the day.